Today we're talking about interval notation and domain and range. We're going to get started by just reviewing some graph on line graphs. So if we're looking at this line graph right here, this is a compound inequality. We're going to graph two parts of this line graph. We're going to graph the part that x is greater than -2. So we're going to put -2 on our line graph. We're going to have an open circle there, and we're going to graph everything greater than. It's an open circle because it's no equal sign underneath the inequality. Our second inequality here is x is less than or equal to 2. So we're going to be over here at 2, and just throw on your number line somewhere so you can just kind of see where it's going to be. You're going to graph a closed circle there because it's equal to, and then you're shading everything below because it's less than. Because this inequality is compound, I like to call it a sandwich graph, and your x is sandwiched in between. Your answer is actually the part that overlaps. So my answer starts here and comes over here to here. Okay, so the actual solution would be this part up here. If you notice though, when you graph this, it starts at -2 from right here, and it ends at +2 right here. And so we can use that example to kind of just graph these other ones that kind of start that same way. So here we know we're going to start at 0, we're going to end at 21, and I'm just kind of throwing those numbers on the number line. We don't need to be perfect on this. Because of the equal sign, I know we're equal at 0, which means I'm going to do a solid dot. At 21, we don't have the equal to sign, so it's an open circle, and because it's what I call a sandwich graph, everything in between there is sandwiched in between. So the x is sandwiched in between those two values, so we're going to just have our graph be that solution. Here we're graphing x is greater than 3, so we're going to put 3 on our number line. It's greater than, not equal to, so we're going to have an open circle. We're graphing everything greater than that, which is to the direction of the right, because this would be 4, 5, and so on to be in the greater than direction. Our last one here is x is less than -3, so put -3 on your number line somewhere. And if this is -3 on our number line, then we're going to have a solid dot there because it's equal to. And we're graphing all of our x values that are less than -3, which is in the direction to the left. So that's our quick review of how we graph. Now we're going to use those graphs to do something called interval notation. Now interval notation helps us decide our solution set, our numbers from left to right, of which would be part of our solution set. So again, just to really quickly graph this inequality here so that you can remember what that's going to look like, you'd start at 2 and you'd end up at 6. At 2 it's a solid dot because of the equal sign. At 6 it's an open dot because of the just being less than, and then you shade everything in between there. So when we're looking at the interval, we're going to write it as a group of numbers for our solution. Well, our solution starts the furthest to the left at 2, and it goes the furthest that it can to the right at 6. So our solution set is the interval between 2 and 6. Because it's equal to 2, just like we use solid dots on our graph, we're going to use a symbol to represent equal to, which is the bracket. Then on the other end of the 6, where it's not equal to with that open circle, we're going to use a different symbol to symbolize that. That symbol is the parentheses. So which symbol means not included or open? That would be the parentheses. Which symbol means closed or included? That would be the brackets. So let's use that information now to write intervals for all of these examples over here on the side. So our inequality is here, our graph is here, our interval notation is what we're writing over here. The leftmost point on my graph is at -2. I'm not equal to -2 though, so I have a parenthesis. The rightmost point on my graph is 2, and because it's got that solid dot there, it's equal to, which means I have a bracket. Same thing here on my next inequality. My leftmost point is at 0. My rightmost point is at 21. At 0, it's a solid dot, which means it's equal to. At 21, it's not equal to, so it's going to be a parenthesis. Try those next to yourself and come and check with Mrs. Clark if you have any questions. Our next examples are where the inequality doesn't end or is not bounded. So x is greater than 3. that's graphed like this. So our interval notation would be the leftmost point is at 3. It will be a parenthesis because it's an open circle, and then it goes on forever, which would be represented by infinity in the other direction to the right. We're going to put a parenthesis around the infinity because we do not know where that stops at. So down here when we're using interval notation, again, if we're talking about going to infinity, it would be positive infinity. And if we're talking about going in the negative direction, it would be negative infinity. Here's some more examples of writing intervals for those. So here we're starting at 3, so the leftmost point would be 3, and it's not equal to because of the open circle right here. And then because we're going forever to the right, we're going to be going to infinity. On this next one, our leftmost point would be negative infinity, and our rightmost point would be negative 3. Negative 3 will have a bracket around it because of its circle. Try those next two on your own and come visit with Mrs. Clark if you have any questions. This is just a chart that shows you or reminds you what your graph should look like with your interval notation according to your parentheses and brackets, and how you would use those if it was equal or not equal to. So how can we represent intervals that look like this? Well, this is a split interval, so we're going to have two intervals to describe it. If we're going to write the inequality for it, we would call this x is less than or equal to 1, or x would be greater than 4. Interval notation, we would have two intervals that we're going to represent with a union or an or sign here. That means we're going from negative infinity to 1 with a bracket, and then we're starting again at 4 and going to infinity, both being parentheses this time. So when we're using two intervals at one time, we're going to connect them with the union sign, which looks like this. All right, here's a couple examples for us to look at to just graph and then write the interval notation for. We have x is less than or equal to negative 5. So graph negative 5 on there. It's going to be an open circle, and we're doing the less than direction. X is greater than 0, so somewhere at 0, you're going to have an open circle and you're going in the greater than direction. In order to write an interval for that, your leftmost point would be that is going to infinity. So we're going to start at negative infinity and stop at negative 5 because it's an open circle. It will be a parenthesis. We're going to union that with our second interval, which starts at 0 and goes to infinity. So our interval notation would be two intervals because we have two parts of our graph showing. These next two work exactly the same way. If you have any questions, come see Mrs. Clark. So how can we represent intervals like this? X is not equal to negative 5. Well, on a graph, I'm sorry, that says positive 5, not negative 5. On a graph, we would put 5, and if it was not equal to, we would shade everything to the left and everything to the right to signify that it was not equal to 5. On the interval, we could write that two different ways. We could say, well, we're going from negative infinity to 5, and then we're going from 5 to infinity. But an easier way to state that would be to say not 5. Either of those would be okay to do. So if I were to ask you to graph x is not equal to 2, you would throw the number 2 on your graph, and then you would have an open circle here. Left and right would be shaded. So again, for interval notation, you could just put not equal to the number 2. You could also write two intervals with a union, but it certainly is simpler to just do this. So what is domain and range? Domain are your x values. And we most oftenly say looking left to right. And then our range are our y values. And that would be bottom to top. So let's look at our domain. Domain would be looking at our x values. This is our x-axis right here. So how far left does our graph go? it goes to -6. So our domain would start at -6. Because of that solid point on the -6 over there, it would be a bracket. And then it stops over here at +5. So 5, and because of the solid dot, it would also be a bracket. If we're looking at our range on this same set over here, our range would be, let me change colors here. We're going to be looking at our y-axis, so how high does my graph go and how low does it go, but we always do low first. So how low does it go, how high does it go? It actually starts at 1 and ends up at 6. Now we're not sure at 1 if it touches because they didn't give us a solid dot there, so we're going to put a parenthesis. And we're not sure up at 6 if it touches, so we're going to put a parenthesis there also. All right, I'm going to work one more example here for you, and then you'll have time to just work on those other ones on your own. If we're going to do domain here, we're going to look at our x values. So where does it go to the left and where does it go to the right? Well, it starts at -2 and it was an open circle, so it's going to be a parenthesis. It stops at 7 with a solid dot, which would be a bracket. Our range goes from bottom to top, so how low did it go to how high did it go? It started at -1 and it ends up at 2. At the -1 it was an open circle, so it's a parenthesis. At 2 it's a bracket because of this solid dot right here. Try the rest of these on your own, and you can come check your note-taking guide against Mrs. Clark's that's in her classroom. Thanks for watching this note-taking guide.